All right, everybody. Hello. Um, Welcome to a very odd class. Odd because neither Allison nor I are here, as well as because I don't have a mic. So I'm just talking through my computer, so the audio is going to be very terrible. But we'll make this class. I don't know if this class will be very quick, but I think it'll be quicker than most. We're going to do a couple things today. We'll just make a big block comment here to articulate those. So we want the goal. Actually, I think I have this. Yeah, look at that. Cool. There we go. Let me delete that and format it nicer. Cool. So the goal for this lecture is to implement a volume calculator for a sphere. And we know that the volume of a sphere equals to 4 divided by 3 times pi times the radius. In order to do this, we need to discuss a couple things: variables, math, and input. Some of these we talked about last time. Really, by some of these, I just mean variables. Variables is pretty much all we discussed last time. So we're going to do a bit of a deeper dive into variables. And then mathematics and input are pretty easy and they'll follow. So right off the bat, last class we talked about text and how we output text. We can output text by first typing C out and then doing little alligator mouths and then surrounding words, whatever words we want to output, with parentheses, or excuse me, quotation marks. When we surround some text with quotation marks and we output it as such, we see here that it gets output to the screen, which is why we can write, maybe, I think last class we wrote, please enter a number, right? And then we ran that, which subsequently wrote, please enter a number to the screen. We can do all sorts of stuff with output, C out. We would just want to keep outputting this over and over and over again. We can see here that we just get this. We just get please enter a number over and over and over again. The reason why this is all conjoined together is because we are not ending the line after we write to the screen. So for instance here, if we write ENDL, which stands for end line, right? End L, end line, and we run this, we now see that we get please enter a number with the line ended, and then get all this mess afterwards. But if we delete that mess and we Control C here for please enter a number, and we output that over and over and over again. I don't know why it's skipping lines, but the format here doesn't really matter as long as you're writing C out. If you run that, then you see here, we get please enter a number. All nice, formatted neatly. You could see here that just because this was tabbed out, just because there's a couple spaces here, and just because we're having like new lines here, this doesn't register for the output pane. We see here that in this panel, in this pane, they're all formatted nicely. They're all just line by line by line by line, even though we might not think from looking at these C out statements here that they'd be formatted nicely. They are. And that's because C++ does not recognize really any spaces outside of a C out statement or any like new lines. All it recognizes is the text itself. So pretend like the C outs and the end L's and the little alligator mouths here, I don't know what you call these, carrots maybe? Pretend like these just don't exist. Your computer will look at the text and see what the text does. So it'll say, oh, it says please enter a number, then the line ends. Please enter a number, then the line ends, etc. Again, if we look at the text, just make a ton of spaces here, C++ will recognize that. It'll say, oh, we have a ton of spaces here. And then it will get formatted weird. But it only gets formatted weird if there's something to do with the text itself. So just keep that in mind. That was basically an overview of pretty much all that we got to last class, at least all that we showed you. We also did work with the backslash characters, so /n, /t, we did /:, I believe, as well, and then of course the greatest one /a. /n, if you recall, just creates a new line. So if we do /n here and then write, actually here, this is a better example. If we do, please enter a number without the end L, and then write again, do there, please enter a number with the end line. What happens when we run this is that we get both lines smushed together, right? Because we're not ending the line here. But if we put a /n there, watch what happens. Boom, they're not smushed together because we ended the line here and we ended the line here, so that anything that comes after this line will come below it because we ended the line. And even though we didn't end the line here, we said, hey, create a new line. This N stands for new line. Similarly, by writing /t here, we can edit the text by inputting a little tab. The /t stands for tab. And of course, as you guys played around with this, you can make many /t's and shoot text way off into the far reaches of your screen. We also did /quote. /quote is really important. Or I should just say that for cout statements, quotes are really important because the text that is outputted is determined by the bounds of these quotes, right? Anything outside of these quotes is not going to get outputted. And moreover, anything outside of these quotes will actually get an error thrown at you. So if we run this, we see error, A was not declared in this scope. That's a very vague error message, but it's basically just saying, I have no idea what the heck to do with this. What is this character? It doesn't make sense to me. Even though we might think, oh, it would make sense just to output A to the screen, C++ says no. And it's because it's not in the quotes. If we want to output A, we have to put it in the quotes, right? So now we see A, please enter a number here. /quote is important because if you are maybe a writer and you're writing something to the screen and you are saying maybe Shakespeare said, you can do /quote. Sorry, /quote. What's a Shakespeare quote? Something English. I am English. I don't know. You can do /quotes here. And watch what happens when we run this. We now get this. Shakespeare said, I am English, right? That works fine. But if we were to just do quotes without the slash, you see, it throws off this whole cout statement because the cout statement thinks that it ends here because this is the last quote. This is the first quote. This is the last quote. It won't recognize anything else that comes after this. If we run this program, we're going to get an error. It says, hey, another really weird error message, unable to find string literal operator. No one can understand what these error messages mean. What this is basically just saying is, hey, I have no idea what to do with this string because you ended it here. I don't know what this stuff is. That stuff does not make sense to me. But if you just put that slash there, it begins to all make sense, right? This is the ending quote. This is the beginning quote. So that's why that works. And then, of course, you don't really need to do /a for anything. I've never used /a at all. I don't even know if my computer will recognize /a at this point. Let's just see if you guys can hear it. Will it make a beep? Oh yeah, did you guys hear that? I don't know if you heard it. My computer beeped a couple times. But yeah, so that's the extent of what we covered last class. I repeat all this because we'll need to use a little bit of it today. But that's the basic stuff with cout. You can't just throw stuff outside of the quotes. You can't throw stuff just after cout or before the carets. You can't throw stuff before cout. And just as a general rule, you can't actually just throw stuff anywhere, right? If we just write a ton of random text up here without any, like, it doesn't know what to do. It says, what is this garbage? I don't get it. If you want to just keep text to look at and as a document, you have to make a comment, like what we did here. Excuse me, like what we did here. This is a line comment and this is a block comment. Block comments are nice because you can just type stuff out. Line comments are nice for single lines. But with programming, you have to be precise. You have to be linear thinking and you have to be literal. So just keep all that in mind. But that's what that stuff does. For reference, we will just say -n creates, ooh, that's capitalized, -n creates a new line, and we'll actually make this a comment block as well, because we're going to be creating a lot of lines here. /t creates a, I think that's equivalent to 5 white space characters. I'm not sure. I think that's the length of a tab. And then let me make that proper. Slash, what do we have here? /quote makes a quote. And I don't know if you guys heard that, my phone just went off. Make like silent there. And then /a makes a beep. Then we will end our comment block right here. What's interesting is that if you fail to end your comment, what do you guys think happens? You see actually what happened there. This stuff got turned into the comment text. Your program, I'm just going to answer, ignore my question, I'm just going to answer this. Your program says, hey, I think that this is part of the comment. If we run this without closing this comment block, I don't know, this compiler will even pick it up. Hopefully I didn't break it. Yeah. So it says, hey, I thought your program was supposed to end. Where does your program end? And it doesn't technically end actually, because we've made what was once the ending just part of our comment. So it's imperative that we end comments, or else they can cause a program to break. But now it's functional, makes it work well. So again, let's return to what we were doing here. Variables, mathematics, and input. A variable is something that stores data, right? Variables store data. What kind of data, you might ask? Well, we went over a couple kinds of data earlier. We went over integers. Let me just write. We went over integers, and I think we talked about doubles, right? And we use doubles or floats. I think we called these floats last time. And then, of course, I don't know if we actually mentioned this too much, but there's these variables called strings, which are basically text, which is what we're working with here. C++, these sentences, C++ thinks that these things are strings. They're certain types of data. They're sentences, they're characters all mushed together. We also talked about chars, which are individual characters. We won't mention those today. We won't talk about strings today either. We'll just talk about integers and doubles for now. We'll tab those out a little bit, because here we're going to create an integer. You create an integer by typing int, then the name of the int. So let's say first int integer. And you can declare it like that. That is an integer variable. That is completely fine. That is syntactically correct. If we run our program, nothing new happens, but it doesn't break. And it doesn't break because this is syntactically correct. You'll hear that word a lot in programming, syntax. The syntax of your code is what matters. Whether it's all legal, every character works, and your program recognizes it, or recognizes that your code is it's readable, it's functional, it's fine. So we have first integer here. And if we want to make a double, we would have to say double, and we'll maybe say first double. Integers store, we just get to always finish off every line, of course, with the semicolon, or else your program says, what the heck are you doing? But we'll talk more about that as we go. Integers, of course, are whole numbers, right? Integers are numbers like 5, 37, and I don't know, something massive too. Big whole numbers. Doubles, or floats, and we'll just refer to them as doubles from here on out, are decimal numbers. They're like 5.6. They're like 37 point, I don't know, 456. And they're like 324, whatever that massive number was, point, something like that. Those are doubles, and those are hits. You can think of them as whole numbers and decimals. You can store data inside your variables by typing equals, and then whatever you want to store in it. So let's say we want to store the number 1 in our first integer. let's say 5. We'll store 5 in our first integer here, and then we'll store maybe 5.5. Well, that might get confusing. We'll store 10.7 in our first double. This, again, when we run our program, nothing breaks because we have defined these things correctly. To define a variable, you need to first write the type and create a space, and then write the name of the variable. And then if you want to assign it a value, you don't have to, by the way, as we already showed. You don't have to assign it a value if you don't want to. But if you do, you would write equals and then 5. And you need spaces in between them. So keep that in mind. But that is how you create variables. These things store data, and they're a little abstract. It might be difficult to kind of understand what the heck we're doing here, but I'm going to show you guys some magic. If we write cout, we've been accustomed now to writing cout like this. We have some text in between quotes. What happens here if we instead want to output a variable? Because you can do that. Watch this. If we type first integer, what do you think is going to be output to the screen? What do you think? I just giggled there a little bit. Boom, we have 5. Look at that. Isn't that crazy? So the reason why we are now seeing 5 down here is because we are saying we have our 3 couts up here, right? That are, please enter a number, please enter a number. Shakespeare said, I am English. We've output all of these. Then we define our variables, and then we output first integer. What is first integer? It's 5. We assigned it that value. What happens if we say, oh, I want to make first integer 598? Well, let's run our program and let's see what happens. We have 598 down here because we're outputting it. Remember in our first homework assignment, we said it's really important to think about programming in the terms of output, input, and constants. This is why output is so important, is because all the data you guys see on your phones, on computers, when you're looking at spreadsheets or charts or whatever, they're all just output. They're all just a machine telling you something. Output is like one of the founding cornerstones of how modern computing works. And you can output a lot of stuff. You can output text, but you can also output numbers. So if we want to make our first integer something massive like that, we can do that. We have something massive. Now keep in mind for C++, I think 2.1 million is the highest we can get for an integer. So there is a limit, right? If I were to just write some massive number, 20, I don't know, that's over 20 trillion. If we were to write that, we get a negative number. And the reason for that isn't really all that important, I think, but just keep in mind that you can't just store crazy large numbers in integer. If you want to store crazy large numbers in variables, they have their own type for that. And I think it's just called int long. It might just be long now that I think about it. Oh, no, it is, right? So if I want to store a crazy high number inside a variable, I'd have to write long after it. Int long. I'm specifying that's a very long, large number. And that works totally fine. But if I were to just write int, then you get a negative number, and that's because an integer can only store 2.1 million, I believe, and we have way over 2.1 million here. So it wraps around and does this weird stuff inside the computer, and it makes for an unfun time when you're trying to do just basic calculations and you get a weird number and your equations are thrown off and it gets all funky. So just keep that in mind. There is a limit to what you can store in variables. All variables have a certain memory that can only store a finite amount of data. Just like your phone has 32 gigabytes or 64 gigabytes worth of data, and it can't store 65 gigabytes worth of data, an integer only has a certain amount of bytes it can store, certain amount of bits it can store, and it can't go over that. So keep that in mind. The same thing applies to a double, same thing applies to a string, same thing applies to all variables. They can only hold a certain number of bits and bytes and data. And if you go over that, then bad things start to happen. So keep that in mind. But the point still stands. You can output numbers here. We have first integer, that's 5. And we could change this to whatever the heck we want, so long as it is in the bounds of what an integer can hold. And you can get up to like 2 million. So the same thing applies to a double here. If we want to output first double, we can do that. See here, 10.7. And just again here, I'm writing ENDL at the end of every cout. I would recommend you guys do that, unless you want to have this problem occur, where you do not have ENDL, and you have numbers that are smushed together. It makes it very difficult to read. And if you're doing calculations and trying to output stuff to users, they won't be able to read it either. So keep that in mind. Write your endls at the very end to keep things nice and neat. But here we see we outputted first double, and we get 10.7. That's awesome. We can output data very easily. And what's cool about variables is that we can write a ton of variables and just output them as such. We can like say, I don't know what's a good example. Maybe we'll get to them in a bit. I think I'm getting a little too ahead of myself. So we have integers and doubles here. One thing to note about variables is that you can't. No, we'll wait. We'll get to that point when we touch on math. So those are variables. You can output variables, and you can store data in variables. We're only doing integers and doubles for now, but there are more. And we'll touch on what those others are in future lectures. So if you perhaps wanted to write a program, for instance, that said, let me get rid of these Shakespeare lines because they're a little annoying. But let's say you wanted to write a program that says, let's see, I don't know. Show me number 17, right? Something. It's kind of a weird program, not all that important. But if we go to first integer here, we can create, we can create a variable called first integer. We can set that to 17, and then we can just output first integer here. And when we run this program, what do we get? 17, right? We deleted the Shakespeare couts, so our program starts here at the very top, and it starts to read down, and it says, okay, well, we see a comment here, so I'm not going to do anything with that. We see another comment here, so I'm not going to do anything with that. We see another comment here, so we're not going to do anything with that. Oh, I see a variable. So it then defines this variable, stores 17 in it. It then sees this variable, stores 10.7 in it, and it says, oh, I see a cout statement, so it outputs that to the screen. And then it says a cout, or sees a cout statement, so it outputs that to the screen. And then the program ends. And the thing it output to the screen here was 17. So that's a very simple program. Show me the number 17. Boom, 17 is shown. Let's get to mathematics, because this is kind of where fun happens, I think. I've never been a big math guy, but math and programming is kind of fun. So let's write first double back here again. So let's create a second integer. Int second integer equals, we'll do, I don't know, 30, right? There are a couple different ways you can do math in C++. And they all revolve around operators. Operators are the things you and I know as like addition, subtraction, division, and multiplication. Let's actually get rid of this first double line again. If we want to say, well, here, I'll just write this. First integer, second integer. This is math. If we output this, what do we get? Oh, forgot a semicolon on line 36 there. Always keep track of those semicolons. So we just outputted this. We ran our program, and what it did was go down the list, sees these two variables, sees these three variables, creates them, then reaches the cout statement and says, okay, I need to output first integer plus second integer. In other words, the program is saying I need to output the product between first integer and second integer, which is 47. First integer is 17, second integer is 30. Together they make 47. That is an example of addition. Oh, addition. Oh, I spelled that wrong. Addition. E-D-D-I-T. Is how you spell addition? I think that's how you spell addition. I think that's right. Correct me if I'm wrong. We can do the same thing with subtraction. And do you guys have a guess on how we would subtract second integer from first integer? Boom. Just a little subtraction sign. If we were to output this, we would get negative 13. Why? Because first integer is 17, second integer is 30. 17 minus 30, negative 13. Subtraction. How do you guys think we would do multiplication? I'm being silent here. Do you think we would do x? Maybe caret? Those are both wrong. Caret actually is an operator that we'll talk about later, but for multiplication, we would do asterisk, the little dot. So what is 17 times 30? Well, we know 17 times 10 is 170. So 170 times 3 is what? 7, 14, 21. That's what? 510, I think? 17 times 30? Yeah. Ooh, right there. Multiplication. And then finally, we can do division as well. And division is, again, you would want to use I think that's backslash. I think this is technically a backslash because for like /n here, we can see that we're using a forward slash. It's a slash moving in the forward direction, I believe. We'll just, I don't know if that's correct. I'm pretty sure this is technically a forward slash and this is technically a backslash, but keep that distinction in mind. For division, you're going to use the slash closest to the bottom of your keyboard. And when you're using /n and /t and /a and whatnot, you're going to use the slash to the upper right part of your keyboard. But that's division right there. First integer divided by second integer. Let's change first integer to 60, right? So our numbers will change here a little bit, but it's because of the example that I'm about to show you after this line of code. What is 60 divided by 30? 2, right? 2 is the answer. 30 goes into 60 2 times. That's division. And so here are our basic mathematical operators. First integer plus second integer. 60 plus 30 is 90. That's our addition. First integer minus second integer is 30, right? 60 minus 30 is 30. 60 times 30 is 180. Right? 60 times 10 is 600. 600 times 3, 6, 12, 18. That's 1800. And then 60 divided by 30 is, of course, 2. The reason why I changed this from 17 to 60 was because, let's say that we go back. Let me make this 17. What do you guys think 17, right here, first integer, what do you guys think 17 divided by 30 would be? I can show you the exact number here. 17 divided by 30, if we just type it in on Google, I'll turn airplane mode on, I think. Did that work? 17 divided by, oh, there we go. We have 0.5666666. What happens if we do 17 divided by 30 here? You guys think we would get 0.56666? No, we get 0. Why do you guys think we get 0? We get, well, think on that for a second. 0.5666666. 0. The reason why we get 0 here is because we're using integers. 0.5666 is not an integer. That is a decimal number. And in C++, integers can't store decimals, right? If we were to change this to double, look at what would happen. 0.566666. The reason why this now works is because we changed int to double. But if we go back to int, we get back to 0. The reason why this is happening is because C++ understands very well that 17 divided by 30 is 0.56666, but it is also able to understand that it cannot store 0.5666 in an integer. So what it does is it just chops off the decimal numbers. Even though this number to C++ is actually 0.5666, the 0.56666 just isn't there. It isn't there because it can't be there. C++ just chops it off. If you want to output decimal numbers, you need to make sure that they are doubles. They are doubles. Doubles can handle the decimal numbers. So let's say here that if we were, let's make 2 doubles, double first double and double second double. And we'll set that equal to maybe 20.673, random number. If we were to say cout first double plus second double, oh, I spelled that wrong. I spelled the capital O. We do not want that. And we output this to the screen. Oh, I made an error somewhere. Expected a comma. Oh, again, guys, I messed up. I forgot the semicolon right up here. Gotta keep track of the semicolons. We get 31 point. So let me go back. We have our 4 CF statements here: 47, negative 13, 5, 10, 0. And then we have our double right here, our 5th CF statement. 10.7 plus 20.673 is 31.373. And that is the product of this. If we want to do division here, we could do run, and then we could see here that 10 divided by 20 is about a half. And we could substitute this division sign for a multiplication sign if we want, and we would get basically 10 times 20, which is about 220. Or sorry, that's about 200, but with the extra decimal points, it bumps the number up a little bit. If we were to do subtraction here, we could, again, we're going to get a negative number here because 10, we're effectively saying 10 minus 20, and we get a negative there, and then, of course, we can add them together, and we'll get a positive number like we did earlier, 31.373. So that is math in C++. What is important to know about math is that when you're dealing, especially with doubles, you guys remember PEMDAS? PEMDAS stands for, what is it? PEMDAS. Please excuse my dear Aunt Sally. Was that the metaphor you guys learned? I remember learning that in school. It stands for parentheses. Yes, I spell parentheses. Parentheses. Parentheses, exponents, multiplication, division, addition, and subtraction. The rules of math. I spell it subtraction. The rules of math are universally true. They are God's word. And they, just as they are true in your math class, they are also true in programming. If we type, let's create a third double. Double, third double equals, let's say, 5.2. If we say first double times second double divided by third double, what are we going to get? I'd be impressed if you guys can do that all in your head in that time. The program here would output 42.5387. But remember that in PEMDAS, multiplication comes before division. Oh, this is a bad example because that should actually be inverted here. Here, that's a way better answer. So your program will say first double divided by second double times third double. But what you always want to make sure is that you're following the rules of PEMDAS. you want the multiplication to go first in this list of or in this kind of equation here. And you want it to go before division, so you have to make sure your multiplication is in quotes. C++ might be, yeah. So now we get a different answer here. And we get a different answer because C++ is not, for how smart it is, it's not smart enough to recognize that what's the word? It takes things as it sees it. So it sees this line of code and it says, okay, I must first output first double times second double. What is first double times second double? Well, it's like 220 or so. And then it says, well, we need to do that number times 5. And what does it do? Makes 2 point. I don't know why it's getting that number, but you're getting a different number. It's weird things happen when you're doing equations in C++. But it says, well, we need to divide first, and then we need to multiply first, or then we need to multiply second. And you don't want to do that. You want to make sure that you're writing your equations properly. And this is totally syntactically correct. You can do this perfectly well. Sorry for that squeak. That's the very squeaky chair I'm on. So at the beginning of the class, we said we want to implement a volume calculator, and we need to talk about variables and mathematics and input. We've gotten variables and mathematics out of the way. Basically, we're just creating little boxes that store data inside of them. And we're using those boxes, we're doing certain things with those boxes, specifically by using these operators, is what they're called in C++, to do math. And that is how we're able to output this stuff down here. PEMDAS matters. Remember that for your math. So we've talked about output. And if we go back to our previous example, we can actually make, if we say, I don't know, please enter, or please make, I don't know, please output some number. Output some number. Instead of now saying cout like 17 ENDL, if we run this again, this would work fine, right? It would work fine if I knew how to code ENDL colon. Never forget your colon, guys. Never forget that semicolon. This works fine. Totally right. Totally correct. But we can also just do first integer. And boom, we get that. We still get 17. Why? Because first integer, looking back up here, is 17. What we can also do is, what if we say, please input some number? Let's go up to our list of variables here and create an integer. And let's call this our input. And we'll just put a semicolon there. We're not going to give it any value. Our input can be entered. Let me go back there. So this is nearly correct. If we were to run this program, nothing would really happen. It says, please input some number, and then it outputs, right? Cout, it outputs our input. And there was no value assigned to that. And so by default, C++ gave it the value of 0. But if we change cout to cin, right? Where cout stood for C output, cin stands for C input. Watch what happens when we do this. Oh my gosh, what did I do wrong? Line 54, no match for, oh, because with cin, I'm so sorry, you guys. For cin, you have to flip the carets. And you do not need the ENDL either. That is how you properly write an input statement in C++. Where output, you're sending things out to the screen, this way to the left. For cin, you're getting input. You're sending stuff to or you're getting stuff from the right. And so if we run this, look at this. We now have the ability to enter something here. And this screen looks different because if we enter a number here, we get this program finished code. We've entered a number, but our program immediately ends. Recall that when we were just doing stuff with cout, we saw our couts, and then we get this program finished with exit code 0. But if we play around with input and we run this, we don't get that program finished with exit code 0. Why is that? Because our program is still running. Our program is not done. Our program has it starts up at the top, reads these 2 comments, understands their comments, and doesn't do anything with them, creates 6 variables here, 2 integers, 3 doubles, and then this input integer. It outputs mathematical products of 4 integers. It reads another comment. It outputs this large cout statement down here of mathematics using decimals. And then it says, please input some number. And then we're on that step. We're inputting some number. So we can input a number, press enter, and then the program finishes. Nothing happens because we're not doing anything with our input, but our program finishes. Just like we can output numbers that we have assigned values to, we can also output our input when it has a value. So if we cout, if we cout our input, look at this. What we're doing here is we're saying, please input some number. Then we're getting this input through cin, and then we're outputting that input. So if we run this, if we type 9001, it outputs 9001 right below it. It wasn't doing this before. That extra 9001 is because of that last line, that final line of code. See, no 9001. So that is how we gather input. Just as massive as output is in C++, and just in programming in general, just as our machines depend on output to tell us stuff, they also depend on our own input, right? The Maps app on your phone requires some input. It requires a destination that you want to go to, and it outputs the route for you to go. If you're flying a plane, the plane, it needs input to do things, right? You need to actually take control of the throttle and the wheel. I'm not sure the correct terminology, but you need to take control of the tools of the plane so that you can fly the plane. You need to give the plane direction on where to go, so that as you're flying, the plane will respond to your input and it will output things to you, like your position on a radar, or your height, or your width, or your roll, or your yaw. Those are all plane terms, I think. But input and output, these are the cornerstones of programming. These are the cornerstones of our modern computing age, is input and output. So this looks very simple, but this basic stuff, output something, input something, output something, that's what our modern age is built on. This little formula here. It's very, 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 very impressive. So that's input. The way in which you do input is you create a variable and you store something inside that variable. Keep in mind, our input variable is of type int. It's of type integer. It can only store whole numbers. What would have happened if we write 5.6789 here for our input? What do you think our output would be? You think it would be 5.6789? No, it would be 5. Why? Because just like we were talking about up here earlier, C++ says, hey, even though I recognize that you have entered 5.6789, you're doing it into an integer, and that's wrong. You can't input a decimal into an integer. I just won't allow it. And so it chops off that decimal point. If you want to have a decimal number as a value, you have to account for that with the type of your variable. You have to change that to double. Double our input. If we run this again, if we type 5.6789, our cout would look like this. 5.6789. It wouldn't be 5 any longer because C++ says, okay, I'm now looking at that decimal number that you've entered, 5.6789, and I can properly output that. Because the thing that you're storing the input into, this thing is what we store that input into. It is of the appropriate type. The type matters so much, guys. So yeah, that's basics. That is the basics of mathematics and variables in C++. And here, we're ready to actually calculate the volume of a sphere. So let's just take this line of code, the volume here. Oops. So the volume of a sphere is 4 divided by 3 times pi r squared. So let's do this real quick. Let's say, let's get rid of this, actually. So what will we need to input here for the sphere? Of these three things, what will we need to actually gather input for? There's only one thing that we need to gather input for, and it is the radius. Why? Because we know the value of pi, and we know the value of 4 divided by 3. 4 divided by 3 is 1.3. Pi is 3.14. Radius, though, can be anything. If we're trying to measure the volume of a basketball, the radius will be different than if we're trying to measure the volume of a gumball, right? A gumball, typically at least, are less large than basketballs. So we need to make sure that we account for the radius, right? We need to say, let's change our input here. Actually, let's just delete that entirely. So of all the variables that we would need here, let's create a variable for pi. Would pi be an int or would pi be a double? Pi would be a double. Pi would be a double because pi equals 3.14, then a ton of other numbers. We're just going to keep it to 3.14. Pi would be a double because it is a decimal number. If we were to say pi must be an integer, it would not work. Pi would basically just be 3. C++ would register pi to be 3, and we don't want that. And we would also need to make another variable here. We're not going to make a variable for 4 divided by 3, and I'll show you guys why in a sec. But we're also going to need to make a variable, oops, I'm getting ahead of myself, for radius. Again, what number would we want, or sorry, what type would we want for radius? Would it be double or an int? That is actually up to you. You saw me write double earlier. It depends what sphere you're dealing with. If you're dealing with a sphere whose radius is only whole numbers, then you can write int radius. And that'd be totally fine because you're only going to enter whole numbers into it. But as soon as you get to spheres that have decimals for radiuses, then you need to account for that. Otherwise, your volume will get thrown off. It is generally just a safe rule that whenever you're doing math, always use doubles because they can handle decimals. And usually when you're doing math, you're going to be dividing, going to be adding, there's going to be some decimals getting thrown around. So we're going to make radius a double here. So let's say, please, let's type a nice welcome message. Let's say, well, we'll make this snazzy. We'll say, welcome to the sphere volume calculator. Please enter a number. Then we'll do like cout. We'll do like a cool like long line. Oops. Boom. I'm sure this is very exciting for you all to watch. Me just formatting text. We'll do that there, and then that there. And then what do we get when we run this? We get, oh my goodness, I'm so sorry, you guys. Semicolons. Never forget them. I always forget semicolons. Oh, semicolons. No, I've forgotten them again. I actually forgot the whole thing. We need to write ENDL here. End line. See, I get paid by a company to program, and I still make these mistakes. So don't feel bad whenever you guys make mistakes in programming. Programming is very difficult. So here we see, welcome to the sphere volume calculator. Please enter a number. This line here, this is where we can do it as /n, because it looks a little clunky. Look at that. Boom. Welcome to the sphere volume calculator. Please enter a number. Here, we'll then go back to this and we'll say Cn, our radius, right? And so now when we run our program again, we can enter, maybe let's say our radius is like 6.78. And then we hit enter and our program ends, right? Because we're not doing anything with the radius, but we've gotten to be able to successfully enter some input for the radius here. And we can see that input if we write Cout radius, right? Boom, right there. Our radius here is, let's say, 7 points, some massive decimal. Oh, interesting, cool. So it looks like doubles can only store up to 5 decimal points. I wonder if you can do double long. Does that work? Let me see if this works. I'm curious now. No, it does not work. Interesting. Okay. So that was something I'd forgotten. You can only, I guess, store up to 5 decimal points, or excuse me, 4 decimal points in a double. And I'm sure there's a way to change that. And I'm sure there's another type. I think you could do floats. Maybe floats are longer, but we'll just keep it as doubles for now. So that's our radius. We can output that fine, but just like we were learning up here with math, we can mess around with operators and variables. So if we want to say Cout radius plus radius, we can do that, right? If our radius is 2.3 and we hit enter, then we get 5.29. Sometimes, like I said, math is a little weird in C++. Sometimes your numbers get a little thrown off. And there are many reasons for why that is, but oh wait, hold on. Oh no, sorry, I meant to say add, not multiply. I was like, why is it not outputting 2 points or 4.6? But that's because I hit multiply instead of add. If we run this as addition and we say 2.5, we should expect to see 5 here. Okay, cool, that makes sense. Confusing myself. But we don't want to do radius plus radius. We're doing a sphere volume calculator. So what do we want to do? The first part is we want to do 4 divided by 3 times something. What do we want to times this by? Pi, right? Oh, look, we've created a variable for pi. Boom, pi times what? It's our radius, right? Radius. If we output this now, we get, let's say 2.5 is our radius. Output it, we get a number here. That number is based off of this calculation. But you guys may have already caught this. This number is actually off. Why is this number off? It is because these are integers and these are doubles. Let's go up to here, the Google calculator again. So we said that we want to do 4 divided by 3 times 3.14 times 2.5. Do we think that the number we get, that's the same exact info that we just entered, right? Do we think we're going to get 7.85 when we do this? No, we get a larger number. We get 10.46. Why is that? It's because of these integers. We are doing calculations with doubles. Let's run that. What happens here? Let's say 2.5. 10.4667. We get a different number. We get exactly what we want. That is the volume of a sphere when its radius is 2.5. It's 10.4667 units. The reason why this doesn't work is because 4 divided by 3 is 1.3. And 1.3 is a decimal. And decimal numbers cannot be stored into integers. When we say 4 divided by 3, what we are saying here is C++ will recognize that 4 divided by 3 is 1.3, but because these are integers, these are just whole numbers, it can't just output 1.3. That needs to be stored. It needs to be stored as a decimal. It just says, okay, I'm just going to output 1. I can't do the 0.3. I'm just going to output 1. So what we're effectively saying here is 1 times 3.14 times 2.5. And 3.14 times 2.5 is, of course, what we got earlier, which was 7 point something. Yeah, 7.85. We need to make sure that we are using decimals. Boom. We get a different, not yet. We get a different number there, 10.4667. And this, you guys, is a sphere volume calculator. This is how you calculate the volume of the sphere. You create the appropriate variables to store the appropriate data, in this case, pi and radius, and you write this. You output some information, you say, please enter a number, you enter a number, and you get this. You can do the same thing for the area of a triangle, by the way. Let's just real quick do. Class is almost over. You guys have been very good. I cannot see you, but I'm sure you've done great. So let's just say welcome to the triangle area calculator. Please enter a number. And then I will not forget to end the line this time. So what do we need for a triangle, right? To the area of a triangle, what is the volume for the area of a triangle? Triangle. It is base times height divided by 2. But more importantly, PEMDAS, remember that? It's base times height must go first, divided by 2. So see out. Welcome to the triangle area calculator. Please enter a number. Well, what number are we going to enter? Let's create a variable for it. Let's say the base and the height are both integers. So we'll say int base and then int height. And then we will please enter a number. So we'll say cin base, and then we'll also do cin height. What will this program do right now? We're back to the sphere. We don't care about the sphere. We want to do 2.5. So now we're at the triangle area calculator. Please enter a number. We'll do 5 and then 10. Base and height. Let's just say here, let's make this more specific. We'll say, please enter the base. Then we'll do 5. And then we'll say, cout. Thank you. Please enter the height. So now this will be a little bit more clear for the user. Please enter the base 5. Nice, thank you. Please enter the height 10. Program ends right here, where it's right there. We aren't doing anything with base, but now we can say cout. Your area is, and then we can also cout our area. What is our area? How do we do that? Base times height divided by 2. Just like we did up here, pi times radius, we can do base times height. Divided by 2. And look what happens here. Run. Welcome to the sphere. We don't care about the sphere. Welcome to the triangle. Please enter the base. Let's say the base is 5. Let's say the height is 10. That is 50. What is 50 divided by 2? 25. We should expect to see the area is 25 when I hit enter. Your area is 25. Nice. Now, keep in mind, you guys, and you guys may have already noticed this, but if you, sorry, so I just blew past the sphere calculator. So welcome to the triangle calculator. Please enter the base. If our base is like 7 and the height is, let's say 9, 7 times 9, what's that? Man, that one always gets me. 7 times 9. 63. If we do 63 divided by 2, is that going to be an integer? No, it's going to be a decimal. 63 divided by 2 is what? 31.5. C++, because we've defined these things as integers, cannot store 31.5 in a number or in an integer. It'll say, oh, well, I can only store 31. And if we hit enter, we should actually expect to see 31, when in reality, the correct answer is 31.5. Yep, 31. If, however, we were to change these to doubles, see what I'm doing here? Change these to doubles, run the program, blow past the sphere calculator. The base is 7, the height is 9. We should expect to see 31.5, and we do. Your area, your proper area is 31.5. Guys, good work. This is basic calculations, basic input, basic variables in C++. We have covered these 3 topics, and we have made a volume calculator for a sphere. What, in addition to your beautiful text art that you got as your homework for last class, I'm also going to ask that for your homework for next week, you do, let's see, what's a good shape to do a calculator of? Let's see. It's a cylinder. Volume of a cylinder. Pi r squared times h. That might not be too bad. We haven't talked about squaring, but squaring is basically just a number times a number. What about yeah, we'll just do cylinder. So think of how you guys can do the volume of a cylinder. What would your calculator look like for the volume of a cylinder? And think on that. Follow this basic formula of output something, gather some input, output that output, and then create some answers based off of that. I'll leave this up here for a little bit so you guys can write down stuff if you want. But thank you so much for being a great class. Sorry I couldn't be here today, and I'm very excited to be there tomorrow. Be there next week. So excellent job, guys. Thank you so much. Have a good one.